Now in this video we're going to look at finding the domain of a function, and I know that we talked about the domain and range of a function earlier in previous videos, but I want to really focus on finding the domain of a function, and this is a really important topic because it's important to understand what values x can take on in a particular function, because remember the domain here we're basically looking at are x values. And instead of trying to identify maybe what x can take on, we may ask the opposite question, say, are there any values of x that will make this function undefined? So if we look at our first function here, g of x equals 1 minus 2x squared. Is there any number that we cannot plug in for x? In other words, if we plug a certain number in for x, is there any number that's going to make this function undefined? Well, this is a nice polynomial function, 1 minus 2x squared, and we can certainly square any number, and we can multiply any number by 2, and we can subtract it from 1. So here, if we're trying to locate the domain, then here we could say it's going to be all real numbers. And you're going to see me probably write this as far as all real numbers. A shorthand notation for this is you'll kind of see this like script R. So if you see me write this, this stands for all real numbers. And another way to write that is negative infinity all the way to positive infinity. So here you have three different ways that we could identify the domain of this particular function. So what this tells us is there's no breaks in the graph. There's nothing that's going to give us something that's undefined. So we can plug any real number in for x. And really, if you recognize any polynomial function, the domain is going to be all real numbers. Now here we have the function f of x equals 3x divided by x plus 5. Now this is one of the situations where if you have a function, we know that if you have a denominator, we know that the denominator of a fraction cannot equal 0. So that's going to be a place that's going to cause a problem for our domain. So if we're trying to find the domain, in particular if we have a fraction, then we know that the denominator, which in this case is x plus 5, cannot equal 0. So if you have a fraction, the easiest way to go about finding the domain is take the denominator, set that equal to 0. So x plus 5 equals 0. If we solve for x, we're going to subtract 5, so x equals a negative 5. So that tells us when x is a negative 5, we're going to end up with 0 in the denominator. Now, be very careful. Negative 5 is not the domain. We found what cannot be in the domain. So here, negative 5 is going to give us an undefined division by 0. So that means the domain is going to be all real numbers. So we could say all real numbers. Okay, there's the notation for all real numbers, where x does not equal negative 5. So we could write it this way. So this is all real numbers except for when x equals negative 5. X cannot be equal to a negative 5. Or we could write it as far as our interval notation. We could say, well, it's going to be negative infinity all the way up to negative 5. So if we think of this maybe on a number line here, we know that our domain is anything except for this negative 5. So this negative 5 is not part of the domain. So that means we could look at negative infinity. So all the way over here, any number over here going out to negative infinity, all the way up to negative 5, but we're not going to include it, so that's why we're using parentheses. And then we could go from negative 5 all the way up here to infinity. So we could write that the interval notation is negative infinity to negative 5, and then we could look at negative 5 to infinity. So that's another way that we could write this to represent the domain. So basically here it can be all real numbers except for negative 5. So anytime you see a fraction, you should be aware, is there any value of x that's going to give you 0 in the denominator? All right, next we have y equals the square root of x plus 4. And here's another example of where we tend to have problems with our domain. We can only take the square root of what types of numbers? We can only take the square root of numbers that are what? Greater than or equal to 0. All right, so we cannot take the square root of a negative number. So here, we're going to take the quantity that's under the square root. We know that this quantity here, anything under the square root, has to be what? Greater than or equal to 0. So the easiest way to find the domain for a square root is to take what's under the square root, set that greater than or equal to 0, and simply solve for x. So if we solve for x, we're going to subtract 4, so that means x is greater than or equal to negative 4. And basically this is going to be your domain. So here your domain is all real numbers where x is greater than or equal to negative 4. So this is the domain. Or we could use the interval notation saying negative 4 is part of the domain because negative 4 plus 4 is 0, and we can take the square root of 0, which is 0. So we could use the interval notation, say bracket negative 4, and we're using a bracket because negative 4 is included, and then we continue to a positive infinity. So there's two different ways we could write the answer. And if we think of a number line again, here we have negative 4. That is part of the domain, so we would have a bracket, and then we would go to the right all the way to infinity. Okay, so here's two of the big cases that we have trouble with the domain. Anytime you have a fraction where your denominator is equal to 0, or if you have a square root, then we can only take the square root of values that are greater than or equal to 0. All right, next our function is f of t equals the cube root of t plus 4. Now be careful, this is the cube root. Whereas up here with the square root function, realize that if we had the square root of 4, we would know that's equal to 2. But if we took the square root of a negative 4, that's undefined. It's not possible, right? Because if we take negative 2 times negative 2, that's going to give us a positive 4. So there's no way that we can multiply two numbers. There's no way we can multiply a number by itself to get a negative 4. Okay? Now, down here, we're looking at the cube root. For example, what is the cube root of 8? Well, the cube root of 8 would be 2, because 2 times 2 is 4 times 2 is 8. Can we take the cube root of a negative 8? Well, of course we can. The answer would be negative 2. And that's because if we take and multiply negative 2 times negative 2 times negative 2, what does that equal? Well, negative 2 times negative 2 is 4. 4 times negative 2 does equal a negative 8. So here, anytime you have an odd index, which is a 3 here for the cube root, we can take the cube root of a negative number. So here, if we're trying to find the domain of this particular function, we can plug any value in for t. So the domain would be all real numbers. Okay, or again, we would identify negative infinity all the way to positive infinity. So we can plug any value in for t for this particular example. All right, maybe you want to pause the video now and see if you can find the domain of this particular function. H of x equals 10 divided by x squared minus 2x. Now, hopefully, again, here you'll notice that we do have a fraction, so that means we're going to have an issue anytime that the denominator equals 0. So we can take the entire denominator and set that equal to 0. And if we solve for x, we'll find values that will make the denominator 0. And here we can factor out of x, and we'd be left with x minus 2 equals 0. Set each factor equal to 0, so x equals 0, x minus 2 equals 0. So x equals 0, and x equals 2. Now, keep in mind, these are the values that give us 0 in the denominator. So these are values that are not part of the domain. Okay, so these are not in the domain. So be very careful. Common mistake is you solve this and you say, oh, well, 0 and 2 is the domain. Well, that's not the domain. The domain would be all real numbers except for 0 and 2. Okay, so be very, very careful. It's all real numbers except for 0 and 2. Now, of course, we could use the interval notation once again, and that would be all the numbers except for 0 and 2. So that means we would go from negative infinity all the way up to 0. And then we would continue from 0 all the way up to 2. And then we would go from 2 to infinity. So that's another way we could represent the domain for this particular function. So here we have our next example. We have f of x equals the square root of x plus 6 divided by 6 plus x. And once again, we want to find the domain. In this problem, we have two situations where we have the square root and we have a denominator. So first of all, if we take care of the square root, we know that x plus 6 must be greater than or equal to 0. So if we solve for x, then we get x is greater than or equal to a negative 6. So that means we can only plug values in for x that are going to be greater than or equal to negative 6. But we have to be careful because here we have 6 plus x in the denominator, and we know that 6 plus x cannot be equal to 0. So what's going to make this 0 is when x is a negative 6. So here x cannot be equal to a negative 6 because otherwise we get division by 0, and that is undefined. So for our domain, it looks like x must be not greater than or equal to negative 6 because over here we eliminated negative 6, right? So therefore the domain is going to be x has to be strictly greater than negative 6. Or once again with the notation, we could write this as parentheses negative 6 to infinity. All right, so be very careful here. The square root is greater than or equal to negative 6, but because of the denominator, x cannot be equal to a negative 6. All right, once again, now we have a function f of x equals x plus 2 divided by the square root of x minus 10. So you might want to pause the video and see if you can calculate the domain for this function. So once again here we have two things we need to consider. We have the square root and we have a denominator. In this case, notice that our square root is in the denominator. So here we have x minus 10. Now pay close attention. We know that x minus 10 has to be greater than or equal to 0 in order to take the square root. Now we also notice that because this is in the denominator, we know that it cannot be equal to 0, so we can eliminate the equal to part and say that x minus 10 must be strictly greater than 0. So if we solve, we would add 10, so therefore x must be greater than 10, and that's going to be our domain. X has to be greater than 10. Or we could simply say parentheses 10 all the way to infinity. All right, so one more example dealing with the square root and division. So maybe again you can try to pause the video and see if you can come up with the correct answer for finding the domain of this particular function. All right, so once again here we have the square root, so we know that here x minus 2 has to be greater than or equal to 0. So that means x has to be greater than or equal to a positive 2. And then because of the denominator, x minus 5, we know that that cannot be equal to 0. So when x equals 5, our denominator is 0, so x cannot be equal to 5. So what's going to be our domain? Now this one's a little bit trickier. We know that x has to be greater than or equal to 2, okay? And x cannot equal to 5. So that means if we're looking for the domain, x is greater than or equal to 2, except for x cannot be equal to 5. So the interval notation would say, well, we can have a bracket on 2 because x could be equal to 2, and then it's going to go all the way up to infinity, but we have to skip 5. So that means we're going to go from 2 all the way up to 5. And because 5 is not included, we put a parentheses, and then we would continue with 5 all the way to positive infinity. So again, there's two ways here we could actually write the domain for this particular function. So recall with the domain, we're trying to find values of x that we can substitute into the function. And a lot of times it's easier to ask the opposite question, what values can x not be equal to? If you have a polynomial, then you can use any real number. If you have a denominator, make sure that your value does not give you 0 in the denominator. And if you have a square root, then you must take the square root of only values that are greater than or equal to 0. So then if you have a function where you have the fraction with the square root, be very careful, because then you can only take the square root of values that are greater than or equal to 0, but at the same time the denominator cannot be equal to 0.